I'm assuming it's for the next presenter because I don't actually need one.
Well, we're adding yet another cable down here.
Okay. With the bucket of water right there. Yeah.
We had the technology group here
Yeah.
a couple months back where they were using this HDMI cable, much like what we're doing here.
Yes.
The HDMI cable actually fell into said bucket of water.
Oh, interesting.
Yeah, made for not so great video graphics. Like that.
Yeah. Cool.
Awesome. Thank you.
Thanks. Time to start? Okay. Good morning, everyone. Good morning. So, my name is Logan Bell, and I'm a senior developer at Media Math. Today's talk, we're going to go over we're going to be going over Go, and really no Perl. I go by Epic Bell on Twitter, and my CPAN ID is Logie, if you can read that. And I also go by the moniker Logie or Epic Bell on IRC. So why Go, and why Go at a Perl conference? Well, they accepted my talk. But we use Go fairly extensively at Media Math, and we also use a lot of Perl as well. And when I recently joined Media Math approximately 7 months ago, and one of the first projects I started with was with Go. And learning's fun, and I honestly believe that it just makes you a better programmer to learn new languages. So just a very brief history of Go. It was created, Rob Pike had a very big hand in it, and Ken Thompson. It was created in around 2007, 2008 at Google. It became public or open source in 2009, and it's at version 1.4, soon to be 1.5. And it's production ready. We use it in production here at Media Math. So with this talk, I'm taking a slightly unorthodox approach to going over a language. What I'd like to do is build a game and walk through as a code review session how this game is built. I built this game for this talk, and it was one of the best ways for me to become better in Go. I also just want to point out that I am probably more of a beginner expert in Go. So just be nice. Okay, so here's a screenshot of what the game we're going to build. This game is an ANSI-based game, and it's called Arena. And if you can't, it's not really coming up very clearly on the screen there, but you see there's two little characters. The point of the game is to move around and to attack each other. And the first person to 5 or lowers the other person's hit points to 5 wins. So let me tell you a little more about it. It's a server-client model. I'll go over the server code, which is written in Go, and the client code as well. It's very simple, and it demonstrates most of the constructs of Go. The typical gameplay is going to be left, right, down arrows. First one to 5 wins, space bars for attacking, and there's only 2 clients that can connect. Okay, so if we were to go out and check this code out on GitHub and take a look at the directory structure, we would see the following files. Now, you'll see a directory there called client, and that's all the client code. Then there's some packages within there, which is board, which is there. You'll see a main.go in there, and that's going to drive what you actually see on the screen. And then the fighter, which I will be going over, is the code for keeping track of the position on the board for the fighter, and there's a unit test in there which we'll demonstrate. There's a main.go, which is the server code. And then there's also a safe hash, which is to demonstrate an alternative approach to doing concurrency in Go with the sync library. But before we dive into the code, I'm going to also take a few sidetracks just to kind of get people up to speed. So we're going to start off with a hello world. So this is Go. It's a very simple language, and actually it takes learning to actually be productive in Go doesn't take much time at all. As you can see, it has some very resemblance to C. It has a package here in main and a function main. So if you were to create a program, you need to have a function main, and that's the first function that is executed. And also you can see that I'm importing a library called FMT or format, and it comes with a print line function, and I'm just printing out hello world. In order to compile hello world, Go comes with an executable called Go, and there's many tools built into this, and one of them is build, and this will actually compile it for you, and it just creates an executable called hello world. So now let's look at some of the server-side code. So the things that I'm going to be going over in this is how to design a basic package. We're going to go over some of the types in Go, Go routines and channels and what they are. We're going to talk a little bit about methods on packages, and interfaces and how they work in Go. Interfaces in Go are very similar, in my opinion, to Java-style interfaces, which I'll show you. And of course, we got to have some unit tests in there, so I'll demonstrate how to write a basic unit test. Okay, so that fighter package, what is it? So here we go. We have a package and it's a fighter. We're importing a few things. The thing that's interesting to note here is that you'll see these like GitHub URLs. So like github.com/logi17 arena client board. Well, that's actually the fully qualified name of where you would find my local packages on the internet. And Go, when you type go build or go git, it will go and find those and pull them down through Git for you. So here is a structure in Go. Now, for those who are not familiar with structs are, they're structs in C and C++. They're like a compilation of different types. So in here, we're actually setting a custom type with a type keyword, which I'll go over later, called fighter. And within it, it's going to contain many different types. The first few are all integers, as we can see. There's an X and a Y value and some other things. We have a kind, which is a string. And then we have something here, which some may not be familiar with, which is called a rune. And a rune is actually it represents a UTF code point in Go. So that character will actually contain a UTF code point. Go actually supports UTF-8, and you can actually just drop UTF-8 code points right into the code bit. Another interesting one there is the message, which is of a custom type called line, and it's also called a channel. Now, I'm going to be going over channels, but channels are a special type, and this is how Go reasons and constructs concurrency. So this will be something that we'll be passing around to some concurrent processes. So other types that Go supports. It supports the Boolean, your true and false, many various numeric types such as int 64s, int 32s, floats. It has an array type. It has something called slices, which is sort of a higher order array, which you can actually append to and grow in size. It has your standard sort of pointers that are similar to like a C pointer. It has functions, which are also first class. So you can pass them into functions. You can pass them into functions. They also support closures and those sorts of things. Interfaces, which I briefly spoke about, which are really just a way to define an API. And it also supports maps, which in Perl terms is like a hash, a key value pair. Okay, so let's talk a little bit about Go routines. So here you can see some code here where we're inside main and we're calling Go routine, Go routine, Go routine. And we have a function actually just called routine. So what this is doing, so when Go compiles and spins up and it's executing main, actually main itself is inside a process called a main Go routine. And for each one of these routines, it spins up a parallel process. If I were to compile this and run this, we would actually see nothing because they all run in parallel and there's nothing blocking or coordinating these calls. So if I were to run this, we would see nothing, most likely. So this is what it sort of looks like. We have a primary routine, and then we have three other parallel routines running concurrently. So how can we how can we coordinate these so that we can block and exit correctly and see the hello world from all three of our Go routines? So this is where channels come in. There is a keyword there called make, and that's just a special keyword to initialize a channel of a string type, and we're naming it done. And what we do, that's actually like a shared memory that we're going to pass into the routine. And the way I think about channels in my mind is I think about them as more like pipes. So if you have a pipe, you have to have an end to put something into it, and you have to have a receiving end. So when the routine is executing, we send a string called done into the done channel. And back down here, back in the main routine, you'll see this arrow, left arrow done. And what we're doing is we're draining the pipe, or we're draining the channel. So it will block that first done until something is received. And it'll continue the block until it gets to the very end, and then we close out the channel. So if we were to compile that and run it, they would run in parallel, but the main Go routine would not close out until all the channels have been drained. Okay, so now let's talk a little bit about how do we do object-oriented. Yes, sure. The first done, so these, there are ways that you can make buffered channels, which would not block, but the first one down here will block, because this is technically it's called an unbuffered channel until it receives something, and then this one will block until something comes across the channel. I'm not certain if that answers your question. Yes, because I have 3 concurrent processes running. Okay, so what it okay, well let me try to clarify it a bit, and then I need to move ahead, and then I can answer questions later. So as we can see, we're spinning up 3 processes with 3 Go routines. So there are 3 simultaneous processes running at the same time, and when we pass something into that channel, we are saying, so the code gets down to this line here, it will block until something is received from that channel. Then we send something into the channel down here, and then it moves to the next line. Sorry, I do not have line numbers, which would have been helpful here, and then we do it 3 times because we know we have 3 processes. Okay, let's briefly go over, there's a lot of code here, but let's just briefly go over how we can initialize something or attempt to do object-oriented style programming in Go, which is a little different than your traditional object-oriented programming. Here we've created a function called newFighter. It's receiving some parameters. You can see that in a function signature, it is a strongly typed language. Find what sort of types are coming in. So we have X, Y, ID, and an int that are all defined. We also are passing in a string, and then we're returning something with a capital F fighter, which is an interface type, and we'll go over what that means. Here we're doing something with mySafe map, which is just really a thread safe hash map, which we'll go over at the end of the talk here, so don't worry. And the key thing here is we see this ampersand fighter and some parameters. And what we're doing is we're actually initializing that struct that we saw earlier. And that ampersand is setting it up as a pointer. So we assign it to fighter. We call some other methods down here, listen and draw, and then we return fighter. Now fighter is a structure type, but it matches the interface of what that capital F fighter is, which I'll be showing here shortly. So how do you create methods on a struct? So for example, if we want to have like a down method, we would have you can define a method to be associated with a pointer based on the type. So the signature is a little different than we saw earlier with the other function, in that you see a receiver. So you see func, and then a receiver, and then the method name, and then parameters. Now, what that is saying is this particular type fighter and will be associated with anything that, let me rephrase that, anything that matches that type will have this method available to it. So Go is a strongly typed language, and so this happens at compile time, and it's able to basically hang this method off of there. So you can see down below that we have another method called draw there, which would have a similar signature as above. Okay, so interfaces. We saw the capital F fighter. So what is that? So this is an interface, and it's another special type in Go. And it's just really, all it's doing is defining method signatures for what a particular type should have. So we're saying that a fighter should have a left, right, up, down method associated with it. This comes in handy later when we want to set up, we can actually set up custom functions that will force us to comply with this particular interface or API, if you want to think of it that way. So it's just, all it is just function signatures and how, what they expect. Okay, so now let's talk a little bit about unit testing. So what we have here is a sort of a basic unit test. Go comes with a library called testing, which actually works in conjunction with the Go command line tool. So when you say Go test, it will actually find any files in your directory that are called whatever underscore test.go, and then it will run the test suite. The testing library comes with a few functions to help with your testing. It's in some ways it doesn't actually come with an assert function or anything like that. It does come with some useful benchmark functions and some error logging and whatnot. So what we can see here is that we're just testing to see that V should equal 8. If it doesn't, then we have a problem, so we just output that. So when it comes to unit testing our fighter, we just have another unit test here. We're going to move left. We're going to test our move left functionality. And basically what we're doing is we're setting up an enemy fighter, and we're testing to verify that can we actually just move into the same space that it's occupying. If it can't, then it fails. So why don't we go ahead and demo how you run a unit test here. And I'm attempting to do this one-handed. Okay. And I think, let's just make this a little bigger so everyone can see. Okay, so in this directory here, we see a fighter.go and a fighter_test. And let's zoom in even more. And we can actually just run go test. And it will test. There we go. So there we go. There's a unit test. Thank you. Okay, so fourth sidetrack. So that type keyword, what was that all about? So one of the interesting things is so you can create custom types in Go, and you can actually create custom types off of primitives, which allow you to do some interesting things. So here we're saying that we're creating a count type, and it's going to be an integer. Now what you can do with that, now that we have this custom type, we can actually hang methods off of it. So we can create this increment method here that accepts a count type. And this is doing a more, so post fixed increments in Go actually return undef. Unlike in Perl, we'll actually return the previous value of what it was. So this is basically allowing us to do an increment postfix that will return what the previous value was. And I have a demo there. So So this is the code here, and so we can compile this. This is the code I just showed. And if we run the type example, it returns 1 because we're returning the previous value. And if we look at the code, it's the exact same code I was just demoing here. So there you go. There's a demo. Okay, so let's go back to the talk here. Okay, so the server code. So let's take a look at that. The primary things I want to demonstrate here is how do we listen for connections? How do we broadcast messages to our other clients through channels? And this will sort of demonstrate some of the concurrency patterns you can do with Go. So with concurrency, as I mentioned, you do it all with Go routines. Channels help with the coordination of these routines. Many of this stuff is actually deeply rooted in a computer science topic called CSP. There's many other languages where the concurrency as like a first-class sort of pattern, like Erlang is an example of this, that have similar sorts of constructs. So let's take a look at that main.go. So what we're doing here, as you can see, so a main gets started up and we create a server object. And then we call a method called serve, which will start serving. If there's an error, then we just print out the error. Nothing too magical going on there yet. Okay, so now the serve method, what we do is we set up we listen on port 120 on localhost, and you can't see where it's actually listening to here, and I don't know where my mouse went. Here we go. Does that work? You can actually see highlighting? Oh, cool. Okay. So we're listening on 127, and it's getting cut off there. It's actually like port 9000 or something like that. And so this is sort of a standard way of, there's a net library, and it binds to this address. We go down here, and we call something called defer. Defer is a special function in Go that allows you to defer expressions or function or defer things until after the function closes. So what we're saying here is when this function exits, we're going to actually call the close function on there. There's some other things going on in here that are not very specific, but the one thing is that down there where you see S server listener accept, that will actually block until a connection is received. If we have an error, we then print it. We create something called a new client, and it starts listening to things coming over the wire. And we'll come back to what this means later. And let's see here. Let me just scroll down a little bit. And then Go routine. So when we get a connection, we actually call Go as handle connection, and that's actually spinning up a parallel routine. And then it goes back up to the top of the loop, and it starts listening for connections again with this parallel routine running, handling that connection. And then we just return out if we're done. Okay, so how do we handle the connection? So one of the things that we do is we set up a special sort of buffer or news reader here, and you see that we have a method there called broadcast. So what that's doing is it's actually passing data into this method, and it will broadcast that over a channel to all the connections that we have. We sit here and we actually just spin in a loop until we receive something here, read line, and then when we receive something, we just broadcast it back out. And we'll demonstrate this here in a minute. So that broadcast is really all it's doing is it's just looping over all of our registered clients that have connected, and using the arrow syntax there, it's passing a message into its particular message channel, and then that will be received. So when we're listening, we loop over each of the messages, and there's different things that we're doing here. So we have something. So if the line, for whatever reason, this is the format that we receive. So we get a line, and then it's going to be, we're going to parse it, and it's going to have an action, an ID, which is the client, and the X and Y. And if the action is a particular, like for some reason we're looking for stab, it'll send an attack message, or we'll just send a position message. And that's for the client so that it knows where to put the character symbol. And finally, so this is the send position message. When we receive something, we send it back, calling the send message function there. So let's just demo that real quick. Okay, so we started a server here, and just one moment, I'm going to try to hold my mic with my elbow. Oh, put it in the holder. That's a great idea. Thank you. I thought that'd be more difficult. Okay, so, okay, so let's go ahead and we can connect here. So what we see is I'm just connecting to 127.0.0.1 localhost port 9000, and the server sent us a message. It sent us a message telling us what our and where we live on the screen. So we can actually send something back to the server, and we can say, hey, my position for 1 is actually 2425. And then it broadcasts back it's just echoing back what it received. So every client would receive that, and it's just sort of a simple broadcast message here. And we go put this back here. And you can see here that the server itself is outputting some messaging. Okay, so let's take a look at the client-side code and how it works a little bit here. Okay, so there's a main, and we are essentially doing a very similar thing here, except this time we're establishing a connection to the server. There's some things going on. We have that board. That board was something I mentioned in a previous slide. That's just another package that does some of the ANSI term stuff. And we close out, we establish a connection. That will actually set up an object that talks to the server. We defer close, so when main exits, we will close this. And we're setting up some initial like fighters, and down here, this down here is how you set up an array. So fighters, arrow. We're saying we're going to have a list of fighters, and it's going to be that player. So that is just one. That's just an array of a single thing of a player there, of the type fighter, which is that interface. And then we call read from server, and we handle key events. So to establish a connection, this is actually returning, if you can see, it's returning a type called netcon. Up above there, establish connection netcon. So this is sort of going to demonstrate how an interface works, because that type there, we'll see here momentarily, is passed into, just one moment. Okay. Where did my slides go? Okay. So it returns a netcon up here, this established connection. And then we turn around and we pass it into a new reader. And new reader actually accepts, you can pass that in, but it's actually defined. If you were to look at the source code for new reader, it would be a different, it would actually be a different sort of type, but the reason you can pass it in is because it matches the interface that is defining. So we can listen to, so we have a read from server here, and this is going to spin up another Go routine, and it's just reading everything that is coming from the server. And it's very similar to the server code. And we block here, and we block until we receive something from the buffer. And then we get we receive data from the line, and we just do some various things depending on what is received here. And then down here, we have a list of connected fighters that we're aware of, and when we send messages, so a client has to keep track of the connections. So it has to keep track of what enemies we have on the board and where they're at. So we send messages back to that. We handle key events based off, we use a library called Turnbox, which actually draws all of the things that you see on the screen. And it handles key events based off of, it has some functionality here. So we just listen until we receive something. And if we receive a particular one, we exit. Now this also demonstrates a case statement in Go. So we just switch until a particular type is received. And the default is we just want to call this connection right. Okay, so let's just see the game actually do something. All right. Okay, so let's start the server back up. And now let's turn on the client. Okay, now we got one guy connected. All right, let's turn on another client. Okay. Oh, so there we go. So you can see I have two clients here. I can't bump into the other one. And then we can, oh, ouch. Okay, okay. Game over. I won. Okay. All right. And my connection to the, I don't know what's going on here. Oh, there we go. Okay. Okay, so I know I kind of went over a lot of code there, and it may not have been clear, so I'm open for questions. If you have questions, feel free to ask. So let's talk about more traditional, like low-level concurrency and what's going on. Has a very nice sync library. So there was something I went over that was called safe hash, and I just want to talk a bit how that works and how it can be used to block without using channels and to make something concurrency safe. So basically, there's a sync library, and it just comes with something called a mutex. And what we do is we set up a structure here which is going to contain our hash. And we're also going to have a special type in there called a mutex. And a mutex is just basically when I have something locked, that means please don't write to me, or you can't write to me, or you can't read from me, depending on how it's flipped. So if we take a look here, we have an insert function. And so what we do, call that mutex, and we say, when I'm inserting a key, I want to lock, and I want to store a value in there after I'm locked, and that means if a concurrent process comes, it will wait until it's unlocked to send its value in, and then we have a defer there that will unlock the mutex. And you can also see, it also comes with read locks down below where you see a find there. So that's sort of the sync library, and that's more of a standard traditional sort of concurrency. And demoing that time. So the interesting about Go here, as you see me typing, there's a thing called a Go path, where all your code gets basically installed. So it's an environment variable. That's why I'm going to home Go. Okay. So if we do the safe hash here, and let me zoom in. And actually, what I wanted to demo here, what did I want to demo here? We can actually see it working here. So here's the safe map here. Basically we're using it as sort of like a shared memory between all the. So I just wanted to throw that in there as an example of how you can have sort of this kind of global shared memory that you can write to and read from within concurrent processes. Okay, so to wrap up here, this is just an example, and it's out on GitHub, and pull requests are totally welcome. And also, do not program like me. Go is a very simple language, but it's also very powerful. One of the things you'll discover is that, wow, I feel very productive in Go, and it's easy to understand and get running with right away. But there's definitely mastering some of the concurrency patterns that it offers are some things that will take time. And you know, as I was sort of saying earlier, why should you care about learning Go? Well, but for me, just learning new languages are always it will make you a better programmer. So, thank you, and thank you, Media Math, for allowing me to have this talk. And I'm open to entertaining questions. Yes.
In your safe hash, I didn't really understand where are you checking if your mutex is locked before you.
Yes. Oh, actually check if it's locked? Oh, okay, yeah. It's actually, yeah, it's not doing that. Yeah. Yes, sorry, he was asking me if I was checking if the mutex is locked, and it's not doing that. Yes.
Also on this, is safe hash something you have to build yourself, or do you just do this as a demo?
I just did. The question was, is safe hash something that you have to build? And no, you do not. I just did that as a demo. Yes.
So Go makes concurrency things much easier than other languages. What else does it? Why else should I use Go? Like, is it a domain language or?
Yes. So the question is, why else should I use Go besides for some of the powerful concurrency constructs? And Go is also known to be very fast. It's a compiled language, so you actually can compile straight to machine code that can be distributed. It's easy to deploy things to production. So that's another reason. Yes. The question was, am I familiar with how the compilation happens? I'm not certain what you mean by. Yes. So is it C? So that's a good question. I don't know. I don't know if I am the person that should be answering that. But from my understanding is that it is C. There is parts of it that with like the latest version of Go that's going to be more. Part of it is in Go itself, the compilation. But I am not an expert in that. Yeah, no, you do not have that. Yeah, yeah, yes.
So if it's supposed to be a concurrent or make concurrency easier, does that mean it can distribute across machines and then have those?
I see. So the question was, if it makes concurrency easier, can you distribute your code across the machines? Is that what you're asking? So you can do that through channels, and it really shines when you're doing server to server or client to server type things. So you just do it over a socket or whatever. So yes, I think that sort of answers your question. But with it, it actually takes the currency is hidden away from the user. So it will when you actually use a Go routine, it's actually very lightweight. They're similar to threads, from my understanding. However, it will use you can spin up 1,000 of them very cheaply, but it will only use how many that you have available for that. So I don't know if that answers your question. Maybe? Okay. Yes. Exactly. So the question, I don't know if it was a question, but more of a statement about channels. And the channel, yeah, I don't know how to repeat that, but yes. I'm going to go back here real quick. Yeah. Yes. In a particular order? Yeah. So if you want a particular order, you can actually. So the question was, how can you control order? And there's different patterns with using channels to do that. And off the top of my head, you could have multiple channels, and so each one could basically be passing in a channel, and you can actually use there's another. I didn't touch on this, but there's a keyword called select, and you can select based on what values are received from the channel, and then do something. So that's one way. Or the other way is you could use the sync library. Yes.
Ghost testing library coming from Perl.
Yes.
Really good testing.
Yes.
Abilities. How does ghost testing compare to Perl? And what other testing library provide other than just an error?
Yeah. So the question was, what does the Go testing library provide, and how does it compare to Perl, essentially? So as I mentioned, it actually offers some benchmarking functions, which are nice. Go is really big on trying for performance. It's very rudimentary, in my opinion, coming from Perl. I feel that Perl has a much richer testing. It has many more richer testing libraries. For example, the testing library doesn't even have a basic assert function. So it exists to make the Go test. So when you type Go test, it will actually go and find those, and it also does the specialized logging. And
So it looks for the ones that import the testing library
yes,
and not the ones that are underscore testing in the name of the file.
I believe it's both, but I don't know the exact details. Yeah. Any other questions? I thought I saw someone back there, but I missed them. Yes.
I was in a fugue state for a second, so somebody might have already asked this. But the broadcast method function,
Yes.
that is like on or against the channel,
Yes.
and that's built into Go.
That broadcast was something I wrote. Yeah. So the question was, what was that broadcast doing? Broadcast was basically looping over an array of connections, and it was sending a message over a channel. And then the channel would receive that message, and it would send it over a connection to.
With regards to channels, can you just dump any arbitrary?
Yes. Well, it depends on its type. So channels are most of them. I was using string channels, but you can or whatever sort of types. Yes. Channels are typed. Okay. Well, it depends on how you write it. You can do it. I was doing it. I see a message. Okay. I'm sorry. Can you repeat the question?
So when you're broadcasting a message, your broadcast routine sends to an array of clients.
Yes.
And when it's doing that, is that turned into concurrent
So the question was, when I was sending messages, was I doing it concurrently or not? And it depends on how you write it. The way I was doing it, I was just looping over it, which was not concurrent. You could spin up a Go routine, which would then do it concurrently. Okay, so I only have a couple more minutes. Any other questions? Okay, well, thank you, everyone.